In this video, we're going to talk about solving trigonometric equations. We're going to do this by looking at some examples. But first, there are some things that we need to talk about. So trigonometric equations contain variables inside trigonometric functions. In order to solve these equations, we must isolate the trig function. We need to find all values of the variable that make the equation true. So in order to find all of these solutions, remember that any multiple of 2 pi, or 360 degrees, can be added to a given solution, and we'll see that in our first example. So we can also verify these solutions graphically, and we'll also do that in our video. So here's our first example. We have solve and find all solutions to 2 sine of x plus square root of 3 equals 0. So again, the first thing that I need to do is I need to isolate that trig function. So I'm going to move this square root 3 to the other side and get 2 sine of x equals negative square root 3. Divide by 2, and I'm left with sine of x equals negative root 3 over 2. So this is where I need to find x values that make this equation true. So I'm going to go to my completed unit circle. So remember, sine of x is our y value, so I'm looking for a y value that's negative root 3 over 2. And that's going to happen in both of these locations, 4 pi over 3 and 5 pi over 3. So I get x equals 4 pi over 3 and x equals 5 pi over 3. But it says that we need to find all solutions. So these two solutions are really on the interval between 0 and 2 pi, which just means that we went around the unit circle once. But if I were to go around the unit circle again, I would then have 2 more solutions. So I need to add 2 pi times k, where k is an integer, to both of these solutions. Basically what this is doing is it means that my answers are basically going to repeat every 2 pi cycles. And this is really important whenever they ask you to find all solutions and not just solutions on an interval from, say, 0 to 2 pi. And we'll see that one in the next example. But I really want to emphasize where this is coming from by looking at graph. Okay, so the first thing that I want to do is I want to graph sine of x. Alright, so I changed both of my axes to show multiples of pi. I'm going to insert another function because we need this function to equal negative square root 3 over 2. So I'm going to graph y equals negative square root, which in graph is typed SQRT, 3 divided by 2. I'm going to change the color. All right, so now I have a graphical representation of this function. I have my sine function, and I want to know when does that sine function equal negative square root 3 over 2. So the solutions that we originally came up with was 4 pi over 3. So looking at graph, 4 pi over 3 is this first one right here. And then the next one, 5 pi over 3, is this one right here. So by adding the multiples, what we're saying is here is my first solution. Here's my first solution. Let me see if I can write on this thing. I know there's a way to do it. Table. So here is my first solution of 4 pi over 3. Here is my second solution of 5 pi over 3. So if you really look at this, if we have our first solution, 4 pi over 3, and I add a multiple of 2 pi, so I would have to get my common denominator. That's going to give me 10 pi over 3 as my next solution. And so right here is that 10 pi over 3. And again, we can do this for 5 pi over 3, add a multiple of 2 pi, and get 11 pi over 3. And right here would be my solution of 11 pi over 3. So as you can see, each time we add a multiple of 2 pi over 3, we're going to get where this green line and red line intersect, which is another solution to this trigonometric equation. So that's why when it asks for all solutions, you need to make sure that you're adding 2 pi k, where k is an integer, in order to get all of those solutions. All right, this next example says find all solutions on the interval 0 to 2 pi. So this means we're not going to have to add that plus 2 pi k because it's only asking for solutions basically one rotation around the unit circle. All right, so we have 2 sine squared of x plus 3 sine of x plus 1 equals 0. So again, we're going to need to basically isolate all those trig functions. So here we have a quadratic equation, and it's really hard to factor that out when it's in this form. So the first thing that I'm going to do is I'm just going to say let u equal sine of x. This way I can rewrite it just using the u's to replace the sign, and you can choose any, letter that you want. But now rewriting it like this allows me to be able to see how I can factor this. 2u, I have a u here, so that when I multiply the first two terms, I get this 2u squared. Then I have to have a plus 1 here, so plus 1 plus 1. So just double checking my work here, if I were to FOIL this back out, my first term plus my outer term, my inner term, and my last term, I do in fact get the same thing I had above. So this is the correct factoring. So now I'm going to replace the u's back with my sine of x. So I have 2 sine of x plus 1 times sine of x plus 1 equal to 0. So now I need to pull these two apart and set each of them equal to 0. 2 sine of x plus 1 equal to 0, and then sine of x plus 1 equal to 0. So now I need to isolate my trig term, move my 1 to the other side. 2 sine of x equals negative 1, sine of x equals negative 1/2 for this one. And then over here, I simply get sine of x equals negative 1. So again, we need to find the solutions on our interval from 0 to 2 pi that satisfy both of those equations. So going to my completed unit circle, I have the sine of x equal negative 1/2. And then I had the sine of x equals negative 1. So again, the sine is my y value, so I'm looking for y values that equal negative 1. And the only place that happens is down here when x would equal 3 pi over 2. Then I'm looking for sine of x equal to negative 1/2, so y value of negative 1/2 right here and right here. So the x values that make this statement true is 11 pi over 6 and 7 pi over 6. So now going back to the original problem, my final answer is going to be x equals 3 pi over 2, 7 pi over 6, and 11 pi over 6. And again, because we were only asked to find the solutions on this interval, we do not have to add plus 2 pi k, where k is an integer. If it asked for all solutions, then we would take each one of these and add that plus 2 pi k, where k is an integer. All right, looking at our last example, we have sine of 2x times cosine of x minus sine of x equals 0. So the first thing that I want to do is I want to replace this sine of 2x with that identity. So I have saved a little trig formula sheet that I have here. So sine 2 of x equals 2 sine x cosine x. So I have 2 sine of x cosine x, and then that was times cosine of x minus sine of x. All right, now if I have cosine of x times cosine of x, that gives me cosine squared x. All right, now I can pull out a common factor of sine and get sine of x times 2 cosine squared of x minus 1 equals 0. Again, now I need to set each one of these equal to 0. So I have sine of x equal to 0, and then 2 cosine squared x minus 1 equal to 0. So since this one is already isolated, I can easily find that on my unit circle, but this one I'm going to need to manipulate just a little bit more. So I have 2 cosine squared x minus 1 equals 0. Add the 1 to the other side. Cosine squared x equals 1. Divide by 2. Cosine squared x equals 1/2. Taking the square root of both sides. Cosine x. Now remember, when you take the square root of both sides, you now have a plus and a minus. And I need to get rid of that radical on the denominator, so I need to multiply both the numerator and the denominator by root 2 over 2. So I get cosine of x equals plus and minus square root 2 over 2. So again, going back to my completed unit circle, we are looking for when sine of x equals 0 and when cosine of x equals plus and minus root 2 over 2. So cosine is my x value, and I need either a positive or a negative root 2 over 2. So that happens at pi over 4. That happens at 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then we need to find where sine of x equals 0. Sine is my y value, so that happens here and here. So I have 0 and pi. All right, so going back to our original problem, our solutions on the interval from 0 to 2 pi are now going to be x equals 0, pi, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So there you go. That's really all you need to know about solving trigonometric equations. Just keep in mind whether they're asking you to find all solutions or solutions on a specific interval. You can also verify your solutions graphically like I showed you on the first example problem. So just keep in mind that you're trying to isolate the trig functions and then find the values of x that make that function true.